introductions here for Paulito and end-to-end AI. And hand it over to you.
Yeah, thank you very much. So I'm Paulito Palmes from IBM Research, specifically from Dublin. I like the ambience of this because usually we present in the pub, so I like the pub setting, which is really appropriate for people from Dublin. So here's the outline of my presentation. So first is the motivation behind the end-to-end AI. What are the main components of end-to-end AI, the Julia AI ML's use case, and then the future. So what's the motivation behind it? So currently, if you're familiar with the infrastructure as a code thing and the MLOps, they are quite separate so that when you try to solve a problem, the assumption is that the infrastructure is already there. But we know that for every deployment that you need an appropriate infrastructure to do that. Without the proper association between them, it's very difficult to infer in the future if you have a new deployment or a new AI solution, what kind of infrastructure you need. So if you place them together, it will be easy later in the future to say that I have this deployment, how much CPU I need, how big is my memory, how big is the infrastructure that I need. And in the future, we are also targeting intent-driven kind of end-to-end AI where you can just talk to the ChatGPT or LLM to say that this is my intent, this is my experiment. Can you give me a YAML configuration to do the infrastructure as well as the MLOps? And that's the dream. So here's the main component. So basically, you need to have a YAML workflow, and that YAML describes your infrastructure as well as the ML pipeline, as well as the lifecycle management. Lifecycle management means that you need to have a certain kind of monitoring when you deploy your application so that when the model is drifting, you need to retrain it. If your infrastructure is drifting, you either scale up or scale down. So you have like you're training an ML, but there's another ML that tries to monitor it. Okay, so there are so many components, and I'm just going to talk about the components above. So data orchestration, pipeline orchestration, and then infrastructure orchestration. The moment you finish this orchestration, you need to deploy them. Take note that when you do this kind of deployment, infrastructure is ephemeral. The moment you don't need it, you delete it. So automation is very important. Training is ephemeral also. Once you finish the training, together with that infrastructure, you delete it because you deploy it in somewhere where the deployment usually don't need a lot of resources because you're not doing a lot of training anymore. So there's a separate kind of thing. So a lot of these things that I'm doing here is automation. If you want to deploy later your Kubernetes cluster at home, or if you have some extra machine, you can use the script, and within 10 minutes, you have Kubernetes infrastructure to play with. So by the way, this is partially funded by the EU project for 3 years. And we are doing experiment to support experimentation in 6G, which will happen all around 10 years from now. And we are talking about terahertz of speed. Okay, so before doing the end-to-end AI, let me refresh you of the package that I created a while ago about pipeline optimization using AutoML. So basically, let's start with loading some of the components of end-to-end AI, like you have certain kind of scaling kind of components, feature extraction components, and then learning components. And the beauty of this is that you can have a one-liner to do this pipeline thing, and you can evaluate that particular pipeline. So here's an example. So I have a data set. The idea is that this is my target. I want to predict whether the football game is away or at home, and these are the features. And I choose this data set because there are some columns here that are non-numeric, so you need to do certain kind of pipeline transformation. So first transformation is that I will select the categorical features from that from that features and heartbeat encoded, and this is the result. So that's one liner. And there are only two APIs, fit, transform, and then cross-validation. So another example is that I have two blocks here. The first block is that I want to get the numerical features, transform it into PCA, and the same numerical features, transform it to ICA, and concatenate the two blocks. So that's another feature. Okay, so now this is another example. So this is now typically become more complex because you have now scaling plus extraction, feature extraction, then another scaling plus feature extraction. Take note that the more you add different kinds of components, the performance of your pipeline may improve or not. So lastly, if you placed at the last part of your pipeline your random forest, you can change the fit transform API into cross validation, which means to say that for this given pipeline, what is the performance of my pipeline given a data set? So let's try to run this if this is quick. Okay, so this is 66% for random forest. If you do the SVM, linear SVM, it's 72% or 73%. So if you ask me which learner is the best, you will not know until you run the pipelines and corresponding to the data. Okay, so you can also do a lot of this parallel processing in Julia. So for example, I want to search for the best learner for a given pipeline. I can do that. And then this is the best pipeline, right? So that's basically the AI solution that I have, and I want this to be integrated in my end-to-end AI framework. So this is the end-to-end AI application. So what you're gonna do, you list down all your machines, the IP address, you choose one of them as the controller, the rest are workers. And then if you follow the IaC script, you will have your cluster like this in less than 5 minutes, maybe, or 10 minutes. Together with that is the observability, because uh, when you try to run your pipeline, you need to observe the status of your network, the status of your cluster, so that when something goes wrong later, you can do anomaly detection. And I use this data set to develop anomaly detection later also. So this is like doing this platform for your development at the same time as a research. And we have published something related to anomaly detection. And then you have this kind of, together with this is a template where instead of creating your program, we already created a template for you. And all you have to do is just change the data and the kind of problem that you want to solve. And this template basically outlines the step to do the prediction or the regression. So here's an example. You can just imagine that each of these steps is a Dockerized solution. It can be written in Julia, in R, in Python, and so on. So here is an example here. This is written in R. This is written in Rust. This is written in Rust. This is auto scikit-learn. So the beauty of this framework is that you can Dockerize your solution, and it's agnostic about programming language. Because this is Julia, I'm using my AutoML pipeline to run this AutoML in that framework. So here's an example where you just submit, for example, the data set. You can change the worker. The complexity means that you want to have a longer kind of blocks. And then you can also even decide to run both sides, where I need to check whether the low complexity is good enough, because low complexity means that the processing will only examine 24 pipelines instead of 576 pipelines. And it can be much more depending on your data set. Okay, so here's more example. And this is an example of the templates that I have. And this is the one that you can change. You can override the templates, and eventually it will be called here. And this is your Dockerized solution, and this becomes your arguments. And this is the vision of the future. We want to connect them together so that you can move your resources to the most appropriate locations of your nodes that have much better GPUs, for example. And with that, I end my presentation. Thank you very much.
Okay, we have time for one question. Does anyone? Yeah.
Yeah, great talk. Thank you for all that. I was wondering, you mentioned it would be AI as a service. Would that mean someone would just upload data, then download a model, and that would be the basic flow of it?
Yeah. So everything, there's an object store basically that you upload your data in that object store, and then you point you can specify in your YAML workflow the location of the data, and everything will run. Yeah.
Thank you.
Good question. Thank you very much.